Right, Math for College. A review of factoring, kind of a factoring introduction here. Um, the first step to factoring is always to look for a greatest common factor. Always, always, always. If there are two parts to it, meaning a binomial, sometimes you can then use a difference of two squares. For example, x squared minus 25 factors to x plus 5 times x minus 5. Um, if you have sum or difference of cubes, like sum of two cubes, like x cubed plus 8, 8 is a perfect cube, then it can factor like the rule down here. We'll look at that later. But x cubed, say, minus 8, the difference of two cubes. We have trinomials, so where there's three terms. So like x squared minus 2x minus 3 factors to x minus 3 times x plus 1. And then you sometimes have polynomials of four terms where you use, say, a grouping option. Whoop, grouping. And that's something we're going to talk about a little bit later. But when you factor something, factoring means to write as multiplication. So for example, if I take the number 18 and I write it as 9 times 2, say 3 times 3 times 2, you can see that it is written in factored form as it is being multiplied. And what's nice about writing things in multiplication is sometimes things cancel or sometimes it's easy to solve. So there's value to writing things in factored form. Similarly, if you have x squared minus 25, that's x plus 5 times x minus 5. So what you see here is the difference between factoring a number and then factoring an algebraic expression. So factoring means to write as multiplication. Okay. So let's look at this first example. It says factor by using the greatest common factor method. So look at the common factor between these two pieces, and it would be 2. 2 times what is 10x? 2 times 5x is 10x. 2 times what is 18? 2 times 9 is 18. And that is factored. Next one, I start by looking at the coefficients. I see they each are divisible by 2. And I see they each have at least an x squared. 2x squared times what is 12x to the fourth? 2x squared times 6x squared is 12x to the fourth. 2x squared times what is 2x cubed? That would just be an x. Then 2x squared times what is 6x squared? That would be a 3. In this situation, they are all divisible by 2. 2 times what is 4x cubed? 2x cubed. 2 times what is 2? 1. 2 times what is 6y cubed? 3y cubed. Get a little crazy here. If you see a lead term that's negative, always take the negative out. Take a negative 2. They all have at least an x. They all have at least a y, and they all have at least a z. Negative 2 times what is negative 12? 6. I would have an x squared, and I would have a y. Negative 2 times what is negative 20? Be a plus 10. I have an x and a z to the fourth. And negative 2 times what is positive 10? Negative 5. And I would have a y to the third and a z to the sixth. Okay, let's try some other factoring options. 80 and 48, they are both divisible by 16. And they both have an x. So I take out a 16 and an x. I'm left with 5y because 16 times 5 is 80. And then I'm left with 3 because 16 times 3 is 48. Again, if you see a negative out front, take that negative out. You're left with d minus 3. So common factor is one way to do it. Another way is to factor trinomials. Trinomials factor very well. Trinomial means that there's three parts. X times x is x squared. I need two numbers that add to 2 that multiply to negative 15. So if you look at your factors of negative 15, say negative 3 and 5, negative 5 and 3, negative 15 and 1, negative 1 and 15. You're looking for ones that add to 2. And so it would be a negative 3 and a positive 5. Same thing here. Two numbers that multiply to 5 that add to 6. 5 and 1. Two numbers that multiply to 12 and add to negative 7. Negative 3, negative 4. Two numbers that multiply to 32 that add to negative 12. Negative 4, negative 8. Two numbers that multiply to 64 that add to 16. 8 and 8. When you have the same expression written twice like that, x plus 8 times x plus 8, you can write as x plus 8 quantity squared. Two numbers that multiply to 1 that add to negative 2. You get minus 1, or x minus 1 quantity squared. We now have the difference of two squares. It's just like what we did up above. We have x, we have x. Now the difference is we want two numbers that multiply to negative 1, but they add to 0 because there's nothing in the middle. Well, positive 1 and negative 1 add to 0. That's what's so great about the difference of two squares. Minus 3 plus 3. You see how the last number is a perfect square, the first number is a perfect square? Because you get the same numbers, they're just opposite, they add a 0 in the middle. Two numbers that multiply to 196. 14 and 14. One is positive, one is negative. Let's try a little bit more difficult. Sorry that these kind of got joined together here. Square root of 4x squared, I'm going to put a 2x and a 2x. Square root of 81, 9 and 9. Plus and minus. $100x to the fourth minus 36. Well, the square root of 100x squared, or x to the fourth, is going to be 10x squared and 10x squared. Square root of 36 is negative 6 and positive 6. Now, as you look at that, you identify that you can take out another factor. You can take out 2 out of each, but we're going to save that for a different time once this factor completely. This one looks different. What do you multiply to get x squared, y squared? Multiply xy times xy. Positive 2, we have a negative 2. To finish off our lesson, we're going to look at factoring completely, okay? So we always start with taking out a greatest common factor. In this case, we could start by taking out a 2. Now we have a trinomial after we've taken that factor out. So we have 2 times x plus 3 times x plus 2. Now I take out a 3. I get an x plus 5 and an x minus 5 because it's the difference of two squares. For 21, what's the common factor? They all have x. Take an x out, you have x squared plus 2x minus 15. That does factor. Two numbers that multiply to negative 15 and add to 2. Plus 5 minus 3. What's the common factor here? 5x squared. When I factor, I get x squared minus 100. 5x squared. I have x minus 10 and x plus 10. Here I factor out a 7. I have x squared minus 6x plus 9. Two numbers that multiply to 9 that add to negative 6. Negative 3 and negative 3. Because those are the same, I can write 7 times x minus 3 quantity squared. 25x cubed, 90x squared 40x. Factor out a 5x. I'm left with 5x squared minus 18x minus 8. Now we're going to talk later on about trying to factor these. What do we do when this front number is not 1 anymore? And right now we're going to leave it because we haven't talked about that, but that's going to introduce what our next lesson will be. A couple more here. I factor out a 2. I'm left with x squared minus 49. So you notice I have the difference of two squares. X and x, positive 7, negative 7. Here I factor out an x. I'm left with x squared plus 10x plus 25. Two numbers that multiply 25 that add to 10. I get x plus 5 quantity squared. Common factor, 8x to the 5th. When we take out an 8x to the 5th, you're left with x squared minus 4. 8x to the 5th times x plus 2, x minus 2. And there we have it. That's a nice review of factoring. 3 different methods: difference of two squares, trinomials, and greatest common factor, and then working to factor completely. Later on, we'll see what you do when you have a different number in front. Right now, that should be enough to get along with your lesson. 12-minute video. Enjoy your day. Ask me if you've got questions.